This is for a simple for loop using MatLab. So we'll start, and for is a magic word. We'll use a counter. I and J are traditional counters. So we'll go from 1 to 3. And for this demonstration, we'll have it print I, and then end is a magic word. And notice the indentation is all automatic. You want to make sure you keep that. So if we run this, we run, the value of I in the workspace is 3, but the value of I changed. It was first 1, then it was 2, and it was finally 3. And you can see with the loop that we started off with 1, I equals 1, we went through the loop, then we came back, I now equals 2, we echo 2, then we come in, now I equals 3, that's the last one, I is echoed as 3, and now we go to end, we're all done, we kick out. A couple of things we can do. We can set the counters outside of the loop. We can say, so begin is my variable. It starts, it's capitalized. End is a magic word, but because I'm using an uppercase in it, it's no longer magic, it's a variable that I created. So I have my begin, my end, suppress their echoes, and now we will go from begin to end, uppercase end. Run it. Oh, yes, we started at 1, went to 2. That's because how big that's the extent of our loop. We can put a step in here, but before we put a step in, let me change the end to 5, and I'll put a step in, let's say 2, run this, and now we have 1, 3, 5. So what happened was we began at 1, it comes through, I is 1, go back into the loop, and 1, we have a step of 2, so it becomes 3. So I is 3, come back into the loop again, we add 2, that's 5, which is also the end. We come through and it works. And just as a reminder, what happens if we do this, for example, you should be able to predict the values, and they're the same values. We went from 1 to 3 to 5, and we couldn't reach the end. Our step was too big to reach the end. And then take note what the variables are in the workspace. Another thing we can do, let me put this back to what we had originally. We can calculate within the loop, and you'll often do this. So let's calculate some sort of sum. We need to initialize the variable outside of the loop. And let me echo that. And now we can say sum equals sum times 2, for example. And this makes no sense mathematically, but it does make sense when working with loops. Let's see what happens. We run this. Our beginning and end, we know what those are. Our I is correct, but our sum now is 8. So let's see if we can figure out what happened. These are the 3 values of sum. So we came in, we initialized the variable sum as 1. So we come in and we say for I equals begin to end, so I equals 1. Sum equals sum times 2. What that means is the new sum equals the old sum times 2, and we get this. Now the new sum is 2. We come up here for a second time, and we come down. The old sum is 2. We multiply it by 2. Therefore, the new sum is 4. We come up again. This is the third and last time we'll be within the loop. Come through. I equals 3, but it doesn't matter in this, what I'm demonstrating. And now we come in and we say that the old sum is 4, so the new sum is going to be the old sum times 2, and sum equals 8. And you can follow here what happened. We could also, if we want to use the I, we could put I in there. If we run this now, this gets a little more interesting. So we initialize sum as being 1. Now for I equals 1 to 3, we come in, the first I is 1. So the new sum is the old sum times I, which is 2. So the new sum, times I, which is 1. Now we come up again, I equals 2, there's I equals 2, and the new sum equals the old sum, which is 1, but now it's multiplied by 2 because I equals 2. Come up around, we're in the loop for the last time, and I equals 3 here, so the new sum equals the old sum, which was 2, times I, which is 3, so the new sum is 6. Let's run that again just to make sure, and there it is. And to be clear, we can now use these variables outside of the loop. So we'll say sum final equals sum times 3. So you should be able to predict what happens here. And the final sum equals the old sum times 3. Thank you.